Alright guys, today we are going to try something very similar to yesterday, except this time we have a parallel circuit. And again, I would normally write this question out, but instead I'm just going to tell you what it is, so please pay attention. So here we have a parallel circuit with an unknown power supply, so we don't know how big the battery is. And notice I used the resistor, a light bulb, and a resistor just like I did last time. So we have an unknown power supply, but I know the power dissipated by resistor number 2 is 10.18 watts. I know the resistance of the light bulb, this is from the last example. I know the resistance of the light bulb is 7 ohms, and I know the current that is going through that light bulb is also 0.79 amps. So I know this is 0.7 ohms, and it has 0.079 amps of current. In resistor, I said that one, doesn't matter. In the other resistor, I know this has a current of 0.61 amps, and it has a power of 3.37 watts. So, what we're going to do is we're going to do the same thing we did last time. We're going to use these two equations, P equals I times V and V equals I times R, and our parallel circuit rules. Now, our parallel circuit rules are a little different. I started them. We have the total voltage. Now, the voltage, again, is the push. And I know in a parallel circuit, I can push the current the same in every branch, which means my V total is the same thing as V1, which is equal to V2, which is equal to V3. So the voltage at every branch is the same. My current rule, that's a little different now, right? Because current is the actual electricity. So when the current gets to this junction point, some can go that direction, some keeps going down. So my current adds up. I1 plus I2 plus I3, etc. Now the reason I didn't write the resistance rule, and we're going to do this twice today, we're going to solve our whole problem two different ways. Our resistance rule is the hard one. Our resistance rule is 1 over REQ, 1 over R1 plus 1 over R2 plus 1 over R3. So our resistance rule is very different. This is the hardest mathematical rule we have for circuits. So now I'm going to do the exact same thing I did before. I'm going to draw that VIRP chart. V I R P, and I know I have resistor 1, I have resistor 2, I have the light bulb, and I have what I called before the total or the equivalent, which is the battery. So now I'm going to try and do all of my work over here. Let's put in the stuff that I know. Like I said, I have it written down. The stuff that I know, I knew that the power at resistor number 1 was 10.18. So the power was 10.18 watts. I know the light bulb, now even though the light bulb is in the middle, I put my light bulb down there, that doesn't actually matter. My light bulb, I had two things. I had a current of 0.79 amps, and I had a resistance of 7 ohms, because I said it was the same light bulb from the previous problem. Then I told you that the current at resistor 3, and I messed that up, the light bulb, 0.79 amps, and 7 ohms. And then I told you the current at the other resistor was 0.61 amps, and the power was 3.37. Oh, I did, right, that's what I did. 3.37 watts. Perfect. So now we go and start solving things. Now the first thing that people start jumping to is our easy equations. V equals I times R, I can do. I need two things here. So it looks like I can't do anything here. I definitely can't do anything at the bottom, but I can work with the resistor 2 and the light bulb. So, gotta grab my calculator. Let's see. V equals I times R. I can't do anything there, but power equals I times V. So step number 1, I'm going to say power equals I times V. This is number 1. Let's see. So I have 3.37 equals 0.61 times V. Power equals I times V. Let's see. 3.37 divided by 0.61. I get a voltage of 5.52. 52 volts. So that's step number 1. Now I can, if I want, I can do this. V equals I times R, just because I can fill up that whole thing. So step number 2, I'm going to say V equals I times R. 5.52 equals I 0.61 times R. 5.52 divided by 0.61 is 9.049, so 9.05. 9.05 ohms. Now what do I do? Well, let's see. I can start doing this, but I know V equals I times R. I can work with that, but I also know my rules. Once I know one voltage, I know all the voltages, which means 5.52, 5.52, 5.52, 5.52, and I can check that if I want. V equals I times R. So 0.79 times 7 is 5.53, so that's close enough. Probably a rounding error, so that looks like it works. Let's see now. V equals I times R. No, can't do that. Power equals I. Oh, I can do that. So now what I'm going to do next, I'm going to come over here. Number 3, I'm going to do power equals I times V. P equals IV. 10.18 equals what I'm looking for. I times V, 5.52. So 10.18 divided by 5.52 is 1.84. So I have a current 1.84. 1.84. Now I can do V equals I times R. That would be number 4, it looks like. Number 4, V equals I times R. Let's see, sorry. 5.52 equals 1.84 times R. So divide 5.52 divided by 1.84. That comes out to 3 ohms. And then if you remember the last example, 3, 9, and 7, it was actually 3, 7, and 9 in the last example. Those are the same resistors, but the board looks totally different. Everything else is changing. I got there, I'm going to do this one. Power equals I times V. So this is going to be number 5. Number 5, power equals I times V. So it's, I'm looking for the power equals I 0.79 times V, 5.52. 0.79 times 5.52 is 4.36 for the power. 4.36 watts. And now we're just at this total line. Now, the total line is where I don't want you to make a mistake. A lot of students will go, bam, that plus that is the total. So what is that? 19.05 ohms. That doesn't work here because my resistance rule, 1 over Req equals 1 over R1, that's a funky rule. Now we can do that right away if we want. I'm going to do that. But most of the time, I'm going to say maybe we should avoid that. Maybe there's a way we can figure everything else out. Well, if I look at my current rule is just I1 plus I2 plus I3. So I can add 1.84 plus 0.61. So 1.84 plus 0.61 plus 0.79. And I have a total current of 3.24 amps. I should put a V there. Now, instead of doing that 1 over R1 plus 1 over R2, now I can do V equals I times R. What we should know in a parallel circuit is the total or the equivalent resistance is always the smallest resistance on the board. So if I did it right, my resistance is going to be less than 3 ohms for an equivalent. So let's see. I'll do this 1, 2, 3, 4, 5. Spot number 6. Spot number 6. V equals I times R. 5.52 equals 3.24 times R. 5.52 divided by 3.24. That gets me a 1.7 resistance. 1.7 ohm resistance. And now the power, I can do power equals I times V, or I can add them up. If I do it both ways, I'll find out that it's right. Just for completion, 10.18 plus 3.37 plus 4.36. Oh, I pressed the wrong button. 10.18 plus 3.37 plus 4.36, 17.91. Now, I do want to check. I do want to go through the hard resistance. So we're going to do that last thing together. 1 over R total equals 1 over 3 plus 1 over 9.05 plus 1 over 7. Now, normally you would need common denominators, but we've learned in physics that I can do all this in my calculator as long as I have parentheses. So I'm going to put in parentheses 1 over 3, close my parentheses, plus 1 over 9.05 plus parentheses 1 divided by 7. So everything, I hope you can see that because I don't know what it looks like, everything you see is in parentheses. Now that equals, and this is where students tend to make a little bit of a mistake. I'm going to go right there. That equals 0.5867. So 1 over REQ equals 0, move that over so we can see, 1 over REQ equals 0.5867. 5867. We're not done. We need to take the reciprocal of both answers. So that means I turn this upside down. REQ equals 1 divided by 0.5867. So now just on my calculator, 1 divided by 0.5867, and I get that same 1.7044, so 1.7. We do need to learn how to do that. We'll have some practice at it, but that's all I have. Please, if you have any questions, by all means, email, just let me know. Thanks for watching.